guest here with us. He's a chemistry expert. His name is Dr. Richard McCreery. He's a chemistry professor at the University of Alberta. And so he's calling in today all the way from Alberta. So thank you very much, Dr. McCreery, for calling into STEM Camp today. All right, so as everyone knows, it is Chemistry Day, and campers are learning about dissolving solids in liquid, dissolving the gobstopper candies, making an oobleck, a super bouncy ball, and crystal snowflakes to learn more about chemistry. So I know the campers will have all sorts of questions to help them with these experiments and projects. But first, Dr. McCreery, can you tell us a bit more about what you do with chemistry, what your research is, and things like that?
Sure. Hello, everybody. As you probably know, chemistry is everywhere, and it takes a lot of different forms. And I used to be, I worked in electrochemistry, which has to do with batteries and that sort of thing. But more recently, I got into looking at chemicals in electronic circuits. So do any of you play a guitar? If you play a guitar, can you wave your hand? Okay, I see you. Well, that's good. Well, electronics is everywhere also. And the idea of what we do is to try to put molecules, chemical molecules, into electronics that are useful for people. And our first product is likely going to be a so-called guitar pedal. I got one here. This is one that's made by a company in Edmonton, actually. And there are hundreds of people who make these things, and all the rock stars have guitar pedals. All right, it goes with the turf. And what it does is to modify the sound of the guitar in ways that are pleasing to the rock music audience. Well, one of my coworkers, his name is Adam Berggren, plays the guitar. So do I, actually. And he said we should put one of our molecular devices inside a guitar pedal, and it would sound neat. Well, it does sound neat. I was playing it last night, and it sounds really quite cool. So it's a case of something that the molecules can do that is not possible with silicon. So it's a so-called molecular electronics. And so this guy is building prototypes for us right now, and we're gonna have them sent out to a couple of big companies and hopefully a couple of professional guitarists. So in this case, we're using chemistry as the molecules are electronic systems. You know, they have electrons in them. That's what holds them together. So you might as well use molecules as an electronic system. And we look at ways to do that, and there's a variety of possible applications that have to do with saving power, going faster, being cheaper, things you can't do with silicon. So that's our main goal. And it involves chemistry, it involves physics. I have engineers that work in the group. It's a very multidisciplinary area, as they say. So do any of you guitar players have a pedal? Well, I'm not surprised, but there is an amazing number out there. Believe it or not, this is one of about 200 companies that make these things. And those 200 companies worldwide sell about $2 billion a year worth of guitar pedals. And a typical guitarist will have 6 or 8 of these things, all with different sounds. So what we want to do is make new ones that have neat sounds. So that's it.
Okay, yeah, thank you for that introduction into your work and how you use chemistry. Let's get to some questions from the campers. Let's start in Ancaster. Was there a camper in Ancaster with a question for Dr. McCreery?
What do you enjoy most about studying chemistry?
Could you repeat that?
I didn't hear it very well.
Yeah. Sorry, Ancaster, could you just repeat your question?
What do you enjoy most about studying chemistry?
What do I enjoy about chemistry?
Yeah.
Was that the question?
Yes.
Well, chemistry is very versatile. If you ask most chemists why they became chemists, they usually have 2 answers. One of them is they like to see solutions change colors and to make stuff. The other is like they like to blow stuff up. So chemistry to me is interesting because it's got a lot of variety to it, and you can make things. You can make new things. I do a little demonstration for classes just like yours, where you make slime. You know, slime is the stuff you can buy at the hobby store. So you can make new things. It's very versatile. It has elements in it from physics and from light and all sorts of things. I like the variety. I don't know why exactly I became a chemist. I mean, I did like to blow stuff up, but that's hardly an occupation. So it's interesting. It's fun. I mean, the nice part about being a scientist is that you can do things that you enjoy and hopefully do something for the world at the same time.
Yeah, good question. Thank you, Ancaster. Let's go to London now for the next question, please. Hi.
How do the elements get their names?
Anne, could you repeat that?
He asked,
How do
how do
the
the
elements
elements
get their names?
how do the elements get their names?
How did the elements get there?
Their names.
Well, yeah, what?
How do the elements get their names?
I think I heard you. How do the elements, how were they created?
How do the elements come to have their names? Like what they're called?
How their names?
Yeah.
Oh, the names came from, yeah, it's a good question. Some of them came from Latin names, like lead is plumbum in Latin. It's got to do with plumbing. Some of them from common names, oxygen. It's the ones that are historic have old names that come to about the first 60 or 80 of them. And then the high elements that were created relatively recently, like in the last 50 or 100 years, they're named after people. So there's an Einsteinium and a Nobelium, Seaborgium. These are named after the individuals that helped discover them. So it's a variety, but a lot of them have their origins in the properties of the material. And lead was used for plumbing, and so that's why it became PB. But it's like saying, why do we call a chair a chair? It's not a lot. There aren't a lot of good reasons in this case, but it's a pretty wide variety.
Okay. I have a question sort of related to that. Do you think that there are still elements yet to be discovered?
So I think there are more elements to be discovered. Well, yeah, they've been adding to the table for 100 years. Everybody thought initially that 92 was the limit, which is uranium. And then with nuclear energy, we discovered that you could make heavier things. The problem is that when they get much heavier, they're rather unstable. So the elements at 110, Einsteinium, that sort of thing, they don't last very long. And when the Earth was formed, some of these things may have been present at that time, but then they decayed away. And so what we see are the elements that have lasted for 4 billion years in the Earth. So there may be, or there's sometimes claims, of a new element, 115 or 116, and they may only made a few atoms of it. But I think the limit will be that they just become very unstable. So they just disintegrate before.
Yeah.
That's what happens above about 105. So uranium, plutonium, they're relatively stable. But plutonium is a good example. I mean, plutonium didn't exist in the Earth for probably 1 billion years until they started making nuclear bombs, and then that created plutonium. So the plutonium that we have today will eventually decay away and be gone, and then if anybody wants it, they'll have to make it again.
Okay, yeah, hopefully without the nuclear bombs.
Hmm? Sorry?
All right, let's go to Ancaster for our next question.
What is chemistry?
How does chemistry,
What is chemistry?
can you repeat it, Anne?
Yes. They want to know what is chemistry?
What is chemistry?
Chemistry. Yeah.
Poetry. No, maybe you could spell it.
The question is, what is chemistry?
What is chemistry?
Yeah.
That's the question? Oh, okay. What is chemistry? Well, chemistry is a study of how the elements are put together to make molecules. And everything you know is a molecule, water, air, slime, etc. So chemistry is the study of how you put different elements together to make different molecules. Some of them have to do with medicine. Some of them have to do with structural buildings. Take concrete. How do you make concrete? Concrete is just chemistry. You take cement, it's calcium oxide, and you mix it with things. So chemistry is about reactions. Reactions are how elements go together and they form compounds or molecules, and those compounds are what we see. So it's the study of that process. So why is oxygen necessary for life? Why is sugar desirable as a taste? Why is it bad for you? All those are chemistry questions. And we of course our bodies, our lives, we're just made up of a bunch of molecules. So how do you put molecules together to make a living cell, or a guitar, or a guitar pedal? And so chemistry is a study of reactions and properties of materials and how you can do things with them. So chemistry is everywhere. I mean, sugar is a chemical. Air is nitrogen and oxygen and other things. Water, etc.
Okay.
You couldn't live
Good
without.
question. No, definitely not. So let's go back to London for another question. Hi. Sorry, I don't know why the audio is a little weird today. Could you repeat your question? Maybe speak up really loud.
What is periodic table and how was it invented?
What is
I heard
periodic?
I heard the first part. What is the periodic table? What was the second part?
And how was it invented?
Okay. So what is the periodic table and how was it invented?
The periodic table.
Yeah.
The periodic table is that's the question?
Yeah.
Right. The periodic. If you take all the elements, let's just talk about the main ones, 92 of them. And you look at all these elements, they have certain properties. And for example, the rare gases are all gases, and the alkali metals are all water soluble. So people noticed that there were these properties, and they noticed that it was periodic. Particularly, a guy named Mendeleev noted that as you go through the elements from the lightest to the heaviest, some of these properties repeated. For example, the noble gases. I mean, helium, argon, krypton. These gases are all inert and they're all gaseous and they don't react with anything. So the reason it's called a periodic table is that you see these sequences. And if you start from element number one, which is hydrogen, and count up in weight, then you'll see that certain properties repeat. They're periodic. So that's how it came to be called the periodic table. And it wasn't invented by any individual. Mendeleev sort of dreamed it up and sort of put the outline together. But when they made the first periodic table, they didn't know all the elements. They only knew about a third of them. So there were holes in the table, and it took another 100 years to fill in the holes. And there's one oddball called technetium, which I think is number 43. And technetium is not stable, so it didn't exist. But there was a hole there in the table, and they finally filled it in by making the stuff. So it was developed over a long period of time, and it is the basic. It's on the wall of every chemistry room, maybe even yours. It's very important in chemistry because it tells you something about the properties of those various elements.
Okay,
And
good question. So I want to go to a question now from Twitter, from our
example.
Sorry, Dr. McCreery, what was that?
I was just going to say another example is you look at the elements that are just to the left of the inert gases, you get ones that are really, really nasty, like chlorine gas, fluorine gas, iodine. These are bromine. These are materials that are quite reactive, and they have similar properties, even though they're only one column over from the inert gases. They're very nasty, to be avoided.
Yeah. Okay. So I want to go to one last question that was actually submitted on Twitter from our camp in Woodstock. So shout out to Woodstock watching the live stream. They want to know an interesting question. Are our thoughts made of atoms?
How are thoughts? You mean as in your brain?
Yeah.
Made of atoms? Well,
Yeah.
that's a very good question. Your brain is a very complex thing. Some people say it's the most complex thing in the world. There are billions of nerve cells that are hooked together. The nerve cells are made of atoms and molecules, and an important subset of those is a membrane. So your brain works by electrical impulses that occur across these membranes, and they're connected in billions and billions of different ways. I mean, there's something like 13 billion neurons in your brain, and they're connected in many more units called synapses. So I wouldn't say that a thought is made out of atoms. Your brain is made out of atoms. Now, people argue, what is consciousness? What does it mean to be conscious? What does it mean to be self-aware? And that philosophers have been talking about that for 500 years. You know, the nature of thought is a fascinating topic. That's the good news, but the bad news is you have to deal with something that's got billions of nerve cells in it. So my daughter actually was getting married on Saturday. My daughter actually studies primitive nervous systems in insects, and she's trying to answer the question of how does this insect think, if that's the right word. How does it know where the food is? How does it know to carry it back to the nest? And it's a fascinating topic, but I wouldn't say that thoughts are made of atoms. I would say that brains are made of atoms. Everything is made of atoms. But the way that becomes a thought, the way that you recognize your grandmother, that's a very interesting question, and nobody has a good answer to that.
Yeah, okay.
When you figure it out, let me know.
Yeah. That's a good, an interesting answer to an interesting question. Lots to think about with that one. So that's all the time we have for our call today. It's already 10:50. So thank you very much, Dr. McCreery, for calling into STEM Camp today. And thank you to all our campers for those really good questions. Thank you.
Thank you.